Hello, everyone. Welcome. Just to mention, at this moment we were supposed to have the talk from Edson Yanaga, who is a Brazilian Japanese. I'm a Brazilian anyway, but I'm not Edson. I'm replacing him in this talk. So you are all invited to be here to understand how not to suck at microservice. My name is Rafael. I work at Red Hat at the same team of Edson. Essentially, I'm a Java developer, okay, but my current role at Red Hat is director of developer experience. Usually, what I like to do in my free time is to build and fly drones. And some people ask me, why you not buy a ready-made drone? Well, usually because I like the freedom of choice, the freedom to choose what's the best motor, the best propeller, the best flight controller, and somehow this is related to microservices. Before starting this talk, I'd like to invite you to join developers.redhat.com. There you can find awesome resources for developers, like for example, this free ebook, microservice for Java developers, building reactive microservice with Java. Also, you can find this the Edson Yanaga book, Migrating Microservice Database, and also introducing ISTO service mesh for microservices. Well, like one year ago, everyone was at the peak of inflated expectations about microservice. Now we are seeing people going through the truth of this disillusionment. By the way, how many people here have tried microservice? Wow, a lot. And how many of you feel that it's painful? Yeah. So maybe you are here having a little bit of disappointment with microservices. In fact, this Twitter is also popular, and it's also funny. We replaced our monoliths with microservices so that every outage could be more like a murder mystery. And it's funny, but also this week also had there was an article that's mentioned that ThoughtWorks will never make microservice in an adopt on their technology radar. The link is right here. Okay. At the end, I will share this slide with you so you can grab all those links that I mentioned here during this talk and check by yourselves all the facts related to microservice. But we are here to learn how to not suck at microservices. The first thing that we need to have in our mind is that microservice is all about agility. It will not make your life easier. In fact, some of you raised your hand saying that you faced some issues, most of them related to testing, because you have different things spread on your cluster and in different servers using different technologies. And because of that, you have issues also with deployment. So microservice is only about agility, nothing more. And of course, there are different situations, different problems when we were talking about a greenfield, a startup company, or a brownfield where we have a company who is producing software, the same software for the last 5 years or so. I've heard about companies that are producing the same software using Java technology for the last 15 years. So you can imagine how painful it is to turn that in a microservice. But no matter if you are a startup company or a traditional company, no matter if you are starting a new project or you are migrating to microservice, you have to go to the same journey in both cases. In this case, the first step to adopt microservices is to reorg your organization and adopt DevOps practices. The next step would be, now that you have a DevOps practices, is to adopt a self-service on-demand less infrastructure, like for example in the cloud. With that, you can start having automation with tools like Puppet, Chef, Ansible, or Kubernetes. So you can adopt CI/CD deployment pipelines. And finally, you can have your first microservice using advanced deployment techniques. And with everything in its place, who knows, maybe you can become the next Silicon Valley unicorn. Well, all those things that I mentioned here is also based on the article of Martin Fowler, where he mentions the prerequisites of microservices. So there are certain requirements to start having microservice. Well, but what happens nowadays when we have our monolith? We all have to agree to run the same operational system, right? Then we all have to agree to run the same Java virtual machine. Should we use Java 8? Should we use Java 9 or 10? Or when Java 11 gets released, should we adopt it as fast as possible? So everyone in the team, from developers or from operations, should agree on the same virtual machine and the same application server. And then we start placing all our piece of code, all our application inside in an enterprise archive. Then we can have our WAR files there. And of course, to avoid duplication of code, we start placing our common code in jar files and build our own libraries. And then that thing starts to grow and grow, and you have libraries, DTOs, entities, third-party Maven dependencies there, and you have a huge beast to manage and deploy. But it's easy because you deploy just this wild beast at once. Well, and to manage this wild beast, we have a huge team of programmers, business analysts, DBAs, operators, compliance, project managers, right? This is what happens in a team to manage this thing here. But what happens in reality is that some part of this big team are divided, and each one of them takes care of an individual module. For example, we have the sales model, the warehouse management system model, the logging and security model, and we have specific teams that takes care of each one of these parts. Let's think about the deployment of a monolith. When we receive a request, we have to implement, test, and deploy everything. We have to test everything, and we need to make sure that the new implementation that we did is compatible with all those modules that I mentioned. And sometimes we can use those practices that we saw on the Martin Fowler prerequisites for microservice. We can adopt, for example, continuous integration and build automation, and that can make our company more agile with those practices. We can adopt technologies like containers and automation that can help us as well. We can adopt continuous delivery pipeline, zero downtime deployment strategies. But in a high trust environment, we can deploy that monolith once a week. But the question is, how can you deploy faster than a 3-week sprint cycle? This book, the Phoenix Project, from Jenkins and others, mentions 10 deploys a day. And how is that possible? It is only possible because you break up a monolith in smaller pieces, where each piece does not depend on each other. So for example, you can have on the first week deploying the module A, C, and D. The next week, you can redeploy the module A because it has a new feature or a bug fix, and deploy the parts H and G, and so on. When you break up your monolith, you have more agility because now each part doesn't depend on other part. You can have, for example, one part of your application using Java with Postgres, another one can use Node.js with NoSQL database, another part can use Spring Boot with MySQL, another one can use Microprofile with Oracle. So building parts that can be independently deployable and that doesn't depend from each other allows you to choose the best technology for that problem and allows you also to deploy at any moment. But you see that in every microservice talk, there is someone talking about the Conway's law. That basically says that if you should care about your communication infrastructure. Because if your communication infrastructure is a mess, very likely you will produce microservices that are a mess as well. Because microservices should be aligned with your business with your business. It's not only about technology itself, okay? Some people, when they see this kind of scenario, they think, oh, that's easy. It's one use case for an integration, and they think that just placing an enterprise service bus, ESB, would solve their problem. But ESB is not microservices, and microservice is not about ESB and SOA. It's not; they are not related. With SOA, with enterprise service bus, we had dump endpoints and a smart pipeline. So the ESB was responsible to orchestrate the communication between those services, to transform and enrich the message. While in microservice, it's the opposite. The pipeline is totally dumb, and the microservices has to be smart enough, and I will talk later with examples why it needs to be smart enough. But there is still a usage for ESB. ESB can be used to integrate different applications, okay? And microservice is about a single application break up in smaller pieces. And when we talk about microservice being smart, we need to also remember that with great power, that there must be also come great responsibility, just like the movie. What are the characteristics of microservices? Well, first one I said, they should be independently deployable. I said also that it should be organized around business capabilities. And we should also focus on the API, because there should be a contract between the invoker and the server, the client and the server. And because of that, because it's very API focused, and we need to deploy them independently, we should also think about evolutionary design. And since we are spreading those services among our network, they will not be on the same server, we should know that they will fail. It's not that they might fail, they will fail at some point, and we should be prepared for that failure. So you should design your microservice for failure. And of course, since we will spread those microservices around among our networks and across our network, among our servers, we should have some kind of infrastructure automation, and each microservice will have its own database. So we need to have a decentralized data management, and of course, this decentralized decentralized governance. And when we talk about decentralized database, sometimes some DBAs can look at you and desire to kill you. So in that case, you can invite him for a dinner and buy him a gift. Just give him this book, Refactoring Database. And also there is the book from Edson that talks about databases for microservices. There are certain strategies that you can use to have your microservices using different databases, and how you can work and not concern a lot about data integrity. That's one of the biggest concern about from DBAs regarding databases. But well, let's understand some invocation patterns for microservices. The first and most commonly adopted is having the browser as a client. So the browser is responsible to locate and invoke each one of the microservices. And what happens for example, let's imagine here this example where you have online store, where each part of the screen comes from a different microservice. So you have the price coming from the price engine, you have the reviews, the details and specifications, location-based availability, and also a recommendation algorithm. What happens if a microservice fails at some point? For example, location-based availability is not responding, it's offline for any reason. Remember what I said about being prepared for failure? So in this case, you should have a fallback. So in the case that, in this specific case here, if the location-based availability is not working, you can, instead of saying, you can pick up in this store, there are 15 items available, you can just use the GPS of this mobile phone and say, well, the closest store is at that address, and you are not losing any sale because you provided a fallback and the system is still available even if one piece of the application fails, okay? There's another pattern called API gateway, is where the client does an invocation to this API gateway, and the API gateway locates and invokes those microservices. Some people ask, is the API gateway a kind of product that I buy from someone? No, the API gateway is just another microservice that can consume and do all these things that I said, like invoking, getting the response. And in a case of failure, the API gateway will be responsible to handle that failure. And of course, you can have a chained invocation. In this case, because it's very common for a microservice to invoke another microservice that needs a data from another microservice and so on. But what happens if something in the middle of the chain fails? Well, that's why I said that the microservice should be smart enough, because the previous microservice should take the decision, what should I do if this service here is not available? Should I wait? Should I notify someone? Should I call the next microservice in the chain? So this is the responsibility of each microservice. And of course, you can have mixed patterns of mixed invocation patterns. Okay, so every microservice has its own concern, and you need to think how that service, besides the technology that you use, how you will build and deploy that service, how we will invoke that microservice, how we will provide tracing, resilience, discovery, load balancing, logging, monitoring, and authentication. And fortunately, we have an answer for each one of these concerns. Most of them, you can see here, that's related to Kubernetes, containers, and OpenShift. Some of others can, for example, tracing, we can use open tracing. For monitoring, we can use Hawkler. For authentication, we can use Keycloak. And I will show you that in a live demo where it's an interactive demo that you can access and try that on your own. Well, think about that chain invocation pattern where a microservice A invokes a microservice B. So what happens when the microservice B is slow? Very likely our user that requested the service A will hit the button several times, right? And that will cause the service B gets even slower. So we need to provide a kind of circuit breaker. And there is an implementation of circuit breaker using the Netflix OSS. There's a library there called Hystrix that can be integrated with Fang. Fang is a REST client. So the invocation is really simple. Besides providing the logger, the decoder for a JSON, you specify a target and a fallback. So what's the implementation of this service if something fails? In this case, it's very simple. It will just provide a fallback response. But you can provide any implementation that's needed. Something good about Hystrix is that every service knows the status of the server. So for example, the payroll service knows a lot about the employee service because it's making the request. And because it's making the request, we can use another thing in the Netflix OSS library called Turbine. Turbine can collect all the data of each Hystrix instance, and then it can you can see those data in the Hystrix dashboard. So you see something like this. You will have all the microservice, and for each microservice, you can see the volume of the invocation, the number of requests, and even the numbers of threads timeout, thread pool rejections, failures, and the number of invocation along the time, and the status of the circuit, if the circuit's closed or if the circuit is open. If the service B is slow to respond, the circuit will open. We will show that in red, saying, I will not even try to do a connection there because the service is not available. If the service becomes available again, then the circuit is closed and you can resume your requests. In a microservice, it's also very common to have some bottlenecks. And you find out that one service is slow to respond and you don't know why. So it's good to have a distributed tracing. So you can track the time spent by each microservice, know how they are behaving in terms of are they responding, are all microservices responding. So a distributed tracing can be implemented with open tracing and Jagger. We will see that in what I call Hello World MSA, because it's a bunch of Hello Worlds, and I guess that you never thought that Hello Worlds could be so funny when I show you this demo. It's like a microservice playground. It's available here at this GitHub URL that I have previously opened here. And here we can see that we have microservices using different technologies. We have the implementation of API Gateway using Java. We have an implementation of Olá, which is a hello world in Portuguese. It's implemented using Spring Boot. We have Aloha, implemented using Vertex. We have the documentation. We have Bonjour in French, it's implemented using Node.js. We have the front end. We have Hola, implemented using JAX-RS, and returns, of course, hello in Spanish. We have the single sign-on. So all these parts, all these different microservices, I have deployed it here on my personal OpenShift instance inside this project, Hello World MSA. So you can see here the Aloha, the API gateway, Bonjour, front end, Hola, and other resources. So let me open the front end here. By the way, you see this URL? You can access that URL with your phone, okay? So you can try, for example, having the browser as a client. It was one of the patterns that I mentioned. So you can click here, refresh, everything is working. You can see the API gateway working as well. You can see the service chaining, where everything's also working. And we can see the Histrix dashboard, where every time that you click, if you are clicking here, you see the volume of invocation growing up. So let me open the Histrix dashboard in another window, and I can show that to you. Histrix dashboard. Okay. It asks for the turbine server. Let me monitor the stream. Oops. And now what I will do is perform some invocation here on my microservice. So let me get the service chaining, for example. So every time that I click on my service, you can see the volume of invocation increasing. And you can see that the response is very fast. But what happens if I remove something in the middle of the chain? So I will stop here the Aloha service. And let's see how it behaves. So I'm scaling down. I don't have any replicas running for the Aloha service. And now when I invoke, you can see that it says that the circuit is opened. I have a fallback here, Hola service circuit opened. Okay, and now the response, it tries once. If the circuit's opened, now the response is still very fast because it knows that it's not available, and it will provide a fallback. Okay. So this is something nice about using a circuit breaker and implemented using Histrix. So I will scale up again, and you will show that when it becomes available, the Histrix dashboard will become green again, saying that the circuit is closed. So let's try. It's available now. Yes. Okay. Let me try one more. Yeah, everything is green, everything is perfect. What about the distributed tracing? We have here the Jagger dashboard. We can open Jagger with some implementation of open tracing. And here we can find specific traces for invocation. So I want to see everything that called the Bonjour service. So I can find some spans here. Let me search for API gateway. API gateway usually is more interesting because it does a parallel invocation. So I have here API gateway, 16 spans. I can see that it called the Hola service, Hola, Bonjour, and probably this one was when Aloha was offline. And we can see here some details. API gateway being used as a client, of course, performing a GET using a camel URL. In this case, you can see that the API gateway uses Apache Camel, and the whole performing as a server. So we have the URL, the result, the status code for that implementation. We can have more debugging info to know what was the span ID, because it uses HTTP headers that are propagated from one service to another. We can also take a look on the dependencies here. So graphically, we can see the number of invocations that the API gateway did on Bonjour, and on which one of these services. Okay, what else we can do that's interesting with this microservice? As I told you, it's a bunch of hello world, but it gets very interesting to play with all these things. Something that I really like is to perform a blue-green deployment. So I have now API gateway. You might try this on your phone, and you see the results. But I have here another implementation of this API gateway. If I want to replace that that implementation, I can come here in this route that points to the API gateway, and I can say point that to a new version that I previously built, and just save the route. And when I try my API gateway, I will see the new version. Hello, JBCN. If something goes wrong, because that's a new implementation that I placed on production, if something goes wrong, I can simply return to the previous microservice. Right? I can come here, select that I want to have the previous API gateway, and when I refresh, now I have the previous version. Very nice. Something also that I like, people like to ask a lot about what happens if a microservice needs to have some kind of security. For security scenarios, it's good to have a single sign-on, because you don't want to, every invocation, you receive a pop-up or be redirected to a sign-on page. You need to sign on just once. And once that you have signed in a sign-on server, you can propagate, for example, an OpenID token that has your credentials, your roles, and allows each microservice to know who you are and decide if you have access to that microservice or not. So if you go to this SSO tab, you will see here that we have the same microservice, but using a secured endpoint. For now, it's unauthorized. And what we will do now is click on the login page. The login page is provided by Keycloak. And something that I really like about Keycloak is that plug and play. So for example, you can see here that I have a Hello World MSA microservice, and I can go to the Keycloak server that's also running here in my OpenShift / Kubernetes cluster. Log in my administration console. And then I can manage this realm. So for example, suppose that I want to enable Remember Me. If I do this, and if I click refresh, it will appear Remember Me. If I want to allow user registration, it's just enable a button, and that will allow me to register. If I want to, for example, enable forgot password and disable user registration, it's just a matter of enabling and disabling some toggles, and that will get me those features. So this is really nice. But something that I really like is that you can integrate that with different identity providers. So you can use, for example, social login with GitHub, Twitter, Facebook, OpenShift, Google, LinkedIn, Microsoft, or even Stack Overflow. In my case here, I have previously set up an integration with GitHub, which is not enabled. I just need to enable it. And when we click, when we refresh that login page, we will see here the GitHub button. I just need to click, and it will return saying, this is a security resource, you are logged in, you are logged as Rafael Benevides. If you try that, you probably will receive a message from GitHub saying, the Hello World application wants to have access to your email, your username, and you just need to allow. You can see that it doesn't do anything else unless that's getting your email and your name. And you might ask, why those other microservices here are unauthorized? It's because Bonjour and Aloha just asks for an authentication, but Hola and Hola asks also for an authorization. So I need to have a user's role. So I can come here with my users, I can view all users. Only I have tried that. I can, for example, come here to role mapping, give me the users, and if I log out and log in again with my GitHub credentials, you will see now that all microservices have access now. Okay, so this is really, really nice. Let me see. Yeah, just myself have tried that. Now, I don't know how many of you have tried, have noticed that there is a typo here. Instead of Aloha, the service says Aloha, which is wrong. So let's try this microservice here, and let me show you also something really interesting, because I want to show that deploy a microservice should also be with zero downtime as much as possible. So let me copy the link, and let's do the following here. While true, do curl this URL /API/Aloha, sleep 1 second, skip one line, and done. Yeah, so we have here, each 1 second, we are consuming that microservice. But now let's fix this microservice. And I will fix that using a CI/CD pipeline. There is here a project called CI, where you have Jenkins deployed. And this Jenkins here is integrated with OpenShift. You can see here that the image is OpenShift/Jenkins, so it's a customized image of Jenkins. And I have here in my builds a pipeline build. You can see that I've tried this pipeline before. And this pipeline points to a source repository. I will open this source repository here of Aloha. And there's also something interesting about the configuration of this pipeline. If you notice here, besides having a configuration of the source code repository, there is also a configuration that says that I will look for a Jenkins file inside that repository. So this Jenkins file has the definition of my pipeline. So I have defined here some stages. It will first do a checkout, then it will perform a Maven build and so on. I will explain it a little bit later. And it also has a GitHub webhook, which means that every change that I perform on this repository, the GitHub will notify my OpenShift instance to trigger the pipeline. So you will see that happening automatically. So let me keep here the pipeline, and let's do a modification in our source code. So let's come here, Aloha vertical, let's edit online. And instead of Aloha, let's say Aloha. And let's commit the change. Note that I just committed, and it automatically started a build in my OpenShift instance. because there is a webhook defined. And here you will see the same stage that I defined here on my Jenkins file. So it checkouts from the source code, which is defined here in the pipeline configuration. It will perform a Maven package, deploy my image on a project called Hello World MSA-dev, and then perform automated tests, because a good pipeline should also be capable of testing, because if the tests fail, then we should not proceed to the next stage. So, otherwise, we are just automating the introduction of bugs on production. So a good CI/CD pipeline should have a nice set of tests. So we can see here that it already performed a Maven build. We can even open here the view log. When we click view log, it will redirect for this customized instance of Jenkins, where the login is integrated with OpenShift. We can log in with our credentials. And then we can see the output console of Jenkins and see what's happening here. So we can see the Maven build, the image build, where we have a Docker file here, the image being pushed to the internal registry. And once it deploys, it will continue to perform the automated tests. Once that it runs the automated tests, it will promote to QA. QA, I have defined here, that's Hello World MSA-QA. Let me open the OpenShift QA just for you to see that the image is being deployed there. And for now, on production, we still have the Aloka version, because all those changes that we did was only on the development environment and now on the quality assurance environment. Okay, and my pipeline is stopped. You can see here that my pipeline is waiting for a human approval before going to a production. But how I will make sure that it's ready to go to the production unless it survived the tests, but I want to manually test my application. So I will open here Aloha-QA. Okay, it's also a good practice to use Swagger, open API implementation, so you can see the REST endpoints that are available. And I can even test. I can come here to this endpoint, Aloha, try it out, and I will get the correct response this time. So in QA, it's right. So I can promote, I'm sure that I can come here to my CI/CD pipeline and answer that I want to proceed and deploy that on production. Something that I did was use a Canary deployment on production. So you will very likely see that during the production deployment, both versions will be available. Not only Aloha, but also the Aloha version, the new version that has the fix. So you have now, there is one failure, but that's fine, Aloha and Aloka, because I choose to use the Canary deployment. Now that I know that this version is working, I can stop the previous version and then just let the right version Aloha working. So this is a good example of CI/CD pipelines. So all those things show to you that microservices can be really easy if you adopt all those practices like CI/CD pipelines, circuit breakers, all those things that I mentioned here in this slide. Have a tracing, resilience. Well, what about microservices versus monolith? The truth is, microservices are not for everybody. In the first slide, where people from ThoughtWorks said that microservices will not reach the adopt status, is basically because they had the conclusion that microservices are not for everyone. So it's not something that everyone should adopt. Of course, some of you might want just a majestic monolith. And a majestic monolith has all those practices that I mentioned, and even so, it can be agile. This article here that I shared in this slide is specifically about how to have a monolith being agile as much as a microservice. Of course, when you decide to adopt microservice, you should, instead of going directly to a microservice, because that's risky, you will find lizards and dragons along the way, you should first have your monolith with all those complexities and components boundaries well defined. Then, as those complexities increase, then you start to break up your monolith in one single microservice. Because remember, to have one single microservice, you need to have all those prerequisites, and having the DevOps practices, automation, CI/CD pipelines, and everything else. And now that you have one microservice, then you finally can continue breaking out your microservices in your monolith in smaller pieces to finally have a software using a microservice architecture. Thank you so much. I hope that you enjoyed. And questions?
So hi, I'm not a purist, but since that was supposed to be a zero downtime deployment, why there was the failure in CRL?
Yeah, I had one failure because the strategy that I adopted required also a modification on a service. I need more time to work on this. But usually any changes on the Kubernetes side is zero downtime. You can see that when I start a version, for example, it takes a while because it needs to have, let me open here, the deployment, health check. That's why I don't have a health check. A microservice should have deployed on OpenShift, should have a readiness probe and a liveness probe. What readiness probe and liveness probe do is verify that my service is ready to receive the request. Having your container running doesn't mean that it's ready. So only when you have a readiness probe, OpenShift and Kubernetes will detect that the service is ready to receive requests, and the load balancer here will start sending traffic to that. So since I didn't configure a liveness probe and a readiness probe, the service was started and I have that small failure. But in this case here, since I started and stopped a service, you should be fine. Okay? You're welcome. Okay, so thank you all once more, and have a nice day all. Gracias.